Yes. Hey, everybody. Welcome to the wasmCloud community meeting for Wednesday, June 26th. Let me go ahead and get the agenda up here so we can take a look at what we've got on deck for today. What we're going to start with is a demo of the secret support in wasmCloud with the NATS KVE backend. Then we're going to move on to doing a little bit of a check-in on the quarter 2 roadmap. It looks like I might have written this a week ago because we've got about a week until the end of June, marking the end of quarter 2. We have a nice little issue and doc of the week, and I didn't actually add this to the agenda, but we will also. Good job, note taker. We will also get to take a look at some of the improvements that have come into, we'll mention some of the improvements that have gone into WRPC over the past couple of weeks, a couple notable ones that I think everybody would be interested in on the wasmCloud side. So let's go ahead and start with secret support in wasmCloud with the NATS KV backend. So let me go ahead and share my other screen. So I'm going to try to do this demo in a little bit of a different order than I normally do. So let's see how all this works. So I'm going to go ahead and run this quick little script, run.sh. This is great, which is the secrets example. So this is going to set up this example, which I'm going to talk through over the next couple of minutes. And the goal of this entire demo is to show the working example of secrets for components and providers in wasmCloud. So I had this little application that requires a password to authenticate with an HTTP API and a password to authenticate with the database at the end. So in order to do this, before secret support in wasmCloud, there would be some level of storing this in config, maybe using an environment variable to be tricky about it. But as with anything that doesn't really have robust secret support, even if you base 64 encoded or whatever, you end up storing it somewhere. So this is essentially a modified version of the key value counter application, where the Redis database that I'm using, if I actually take a look at connecting to my local host, I have Redis running now, and I try to do something like list the keys. It'll say, hey, you need to authorize, or you need to authenticate in order to interact with this database. And if I try to curl localhost 8080 and increment a counter like I normally do, I'll get an unauthorized back. So great. Look, we did some authentication in wasmCloud. Now, what I can do is show you that if I provide a header on this HTTP request and actually give my super secret password, open sesame, I can increment the counter in this key value database. So this is working as intended. It's kind of just like it's an example of API authentication. Now, this is a wasmCloud application that I'm running. It's a component, a provider, and then the HTTP server provider, which is running, just stock out of the box. And all of this was done in the wasmCloud context without storing or transmitting any secrets in plain text. So this is the working example of secrets. Now, let's talk about how this actually works. So I'm going to go back to, actually, why don't I go ahead and show the code? That's a little more exciting. So on the capability provider side, secrets are really, really simple to work with because the capability provider doesn't actually make requests for secrets on its own. Basically, wasmCloud fetches the secret on behalf of the capability provider. And then at runtime, I can grab a secret directly out of that data that we pass to the provider. This is all done over standard in, so nothing insecure happening here about storing. But this capability provider is basically a modified version of the key value Redis provider, where connecting to a database that needs a password is done by fetching a secret at runtime for that Redis password. And then the component, and that does the actual authentication to Redis, and then I can increment the value in the key. The component Oh yeah, go ahead,
Sorry,
Tom.
the value stored in nats.
The value is stored in nats as the
Okay.
backing store. Yep. Um, and I'll talk about the setup that I had to do for that and like how this actually works as well. The component itself has essentially a modified version of the key value counter. I've added this nice little block to make sure that the user is authorized before I actually enable a request to go through. And if not, we send back on unauthorized. The way that this works is we use a new interface called wasmCloud Secrets, and we get the API password out of the store. And then we actually, and this is really important, we get a resource to a password. So this is not the actual secret itself. It is a resource handle, a component resource handle. Then we can use the wasmCloud Secrets Reveal interface to reveal that secret and then compare it to the password that we provided in the host header. Now, I know that this isn't like the best way to do API authentication. The point is just to show fetching a secret from a component and then revealing the secret in the component, which we may or may not want to be able to do forever, but we'll talk about that a little bit later. Now, this interface, the wasmCloud Secrets interface, is something that we're proposing as a part of secret support. And this is essentially the first reference implementation for what could be a WASI secrets interface. So when designing this interface, we talked with a couple people in the WASI in WASI land, not a maintainer, not a contributor of wasmCloud, and tried to design the best interface for a component to be able to access secrets. It's very simple. When we get a secret, all we get back is a secret resource. And then actually revealing the secret itself is when you're able to pull out the secret value. So that's kind of what the code looks like. And in order to actually talk about what's going on under the hood, I think I'll go back and share the RFC to talk about how this is organized. So I'm using the NATS KV implementation or the NATS KV backend of the of for the NATS KV secrets backend. The way that this works, and shield your eyes if you're on dark mode and everything. The way that this works is when a component or a provider at runtime needs to fetch a secret, we essentially, just like all the other things that we do for declarative, we declare when you start the component or the provider that you need access to a specific secret. And secrets are just a special type of config. So when we need to fetch a secret on behalf of a component or a provider runtime, we will grab the secret reference out of the config bucket. So the reference to the secret is just a combination of the key that you should be fetching the secret at, the backend you should be fetching the secret from, like NATS-KV or Vault, and then an optional version if you wanted to, expire a specific secret, get a newer version of a secret, something like that. So when a component at runtime says, hey, I need to get the secret, what the host has done right when the component started is use the pluggable API that we're using for secrets in wasmCloud. Ooh, get out of here. And we resolve that secret by sending a message over NATS to the backends configured. So this is wasmcloud.secrets.natskv, get this secret that the component needs. The NATS KV backend that's running here is a separate process, a separate binary. But what it does is it looks up if the identity of the component or the provider that's requesting the secret is allowed to access that secret, which is something that you configure. It's called a mapping. And then if so, we actually retrieve the secret from the NATS KV bucket. It's already encrypted when it's stored in the bucket. Everything is stored in, this is complete encryption at rest. And then we send that secret back, which the host is then able to decode with an X key. And these X keys is kind of like an in key, but this is all internal to the host. And I can talk a little bit more about X keys in a second as well. But the TLDR here is that the API for retrieving secrets in wasmCloud is really nice because wasmCloud itself isn't actually storing any secret values. All of the secret values are being stored in your configured secret store. When you retrieve a secret, that's all done over the NATS message bus, but the secret is entirely encrypted. So and it uses a request specific X key or encryption key that the secrets backend uses to encrypt that secret, so that when the host fetches it, it can decrypt that secret. And I'll leave the extra details there for folks who would like to take a look at the secrets RFC. I think there's plenty to talk about here, and uh, plenty to emphasize in terms of the technical merit here. But I want to focus a little bit more on how I set this up, and then I can take any questions there. Yeah, Masood, go ahead.
Great. My question is that where the X keys are stored.
Yeah, here, let me go ahead and show you that little run script that I used at the start of this. I think that'll be pretty illustrative to how this works. So the way that I set up this demo is essentially the whole manual process for setting up the secrets backend and the infrastructure for this demo. So this run script does a couple of things. First thing it does is starts Redis requiring a password, and then starts Nats with Jetstream. That's very fun. Just a fair warning, a lot of this script is something that I kind of hacked together to prove the secrets implementation works. So there's plenty to clean up here in terms of operational efficiency. And then we start the NATS key value secrets backend, which is configured with a topic. The topic prefix is wasmCloud.secrets. And then I generate two encryption keys, or two X keys. One is the actual encryption key that only NATS KV, the secrets backend, knows about, which is how it encrypts its secrets to store in NATS KV. And then a transit key, which is an X key that we need to use to put secrets in the store. It's how we're going to encrypt it over the wire. So I run the NATS KV secrets backend. This is going to be a binary or container that you can run. And these X keys actually don't need to be shared with the host at all. The host doesn't know anything about this. Now, in order to actually set up these secrets or to store them in NATS, I made a little Rust utility because this was the easiest way for me to do it. And I stored my API password and my provider secret, which is a wasmCloud secrets type. It's just you can do either strings or binary data for secrets. And the way that this works is by generating a request specific X key and using that specifically to seal or to encrypt the actual secret value along with the transit X key public key that the NATS KV secrets backend knows about. So this is just the setup script essentially to put the key or put the secret in the key value store. But all of this is encrypted over the wire. If you subscribe on NATS during the setup script, you won't actually see these passwords transmitted anywhere. So after that, the next thing that we have to do is tell wasmCloud or tell the NATS KV backend that when this component starts in wasmCloud and it asks for the secret API password, it should be able to access this secret. So in addition to all of the layers of security around encrypting the secret itself, requiring a specific X key for the secret, what we do is we tie the secret name to the component or the provider's identity. Now, we've talked a little bit about this before, but if you look at any component or provider and you use wash, like wash inspect, to take a look at that component, not that one, that one. If you inspect the component, any component or provider that's built with Wash Build has an included account or an included issuer and workload identity. So this public key is tied to this specific component, and that's what we're going to allow to access the API password secret. Same with the capability provider. So if we take a look at the secret provider, build RGZ, there we go. this has a specific public key tied to this capability provider. And the generation of this is done automatically when you run wash build, but managing that secret, if you're going to actually be managing secrets in wasmCloud, is really important because the identity, this allows you to do really coarse-grained, really fine-grained management of what workloads are allowed to access which specific secret. Yeah, Colin.
So the idea is you would have the secrets for your application in a provider specific to your component. Sounds like that's what I'm seeing.
Um, you would, could you say that again?
Sorry.
Actually,
So if I have an application and I've got a component for it, it's just like an easy thing, and I had some secrets, I would also want to have like my application would have its own very specific secrets provider that only it would be able to access have access to, right?
that's right. Yeah.
I know that with the kind of the idea of having multiple multiple components use the same provider is something that like we've talked about. But in this case, this is not something we would not want to have, right? Shared secrets between applications. I mean, I guess we'd allow people to do it, but that's not kind of the golden path or whatever.
Yeah, yeah. When you actually make a request for the secret inside of the host, the information that we send along is, the secret key. So like in Nats KV, it can just be a name, and Vault, it would be a path. The secret's back end to make sure it gets routed to the right place. The identity of the component, so the provider, and the application name if it was running as a part of an application. So each secret you can configure to be scoped to a very specific component in a very specific application. Now, you could configure multiple applications to be able to access the same secret. Say you have an HTTP server that needs to trust the same like common certificate that you need to distribute around. You can make sure each application could access that one secret. It's so
By
you.
by getting access to by allowing multiple secret providers access, or by having one secret provider and having multiple components
You could have
access.
one secret. You could have one. When you say secret provider, are we talking about the provider that's getting
I'm
the secret or the
Yeah, I
backend?
thought you have a secret. I'm looking at the screen you're sharing. Secret provider, capability provider.
Yeah, this is a capability provider.
Right.
I just
So,
want to make sure you're saying the same thing.
yeah. Sorry. I forget what we call these things because I know do we still call them? All right, never mind. But yes. So I'm just thinking like, is the paradigm like you say, hey, I mean, obviously we don't want components. We don't want components that shouldn't have access to secrets, not having access to secrets. But I'm just trying to understand like what the intention of how secrets map to providers have been mapped to components. We still say capability provider. Thank you.
We do. We do.
But
Yeah, the point of this mapping is to allow you to only allow a very specific component or capability provider to access a specific secret or set of secrets. And so
can I add something? I
uh,
think the confusion comes from the fact that we're talking about secrets being available to components and providers. So your secret provider, Karin, is the same. It's just that a provider might need a secret or a component might need a secret. You don't need to separate secret provider per component. You don't have to do that.
that is correct. You only need you can have one secrets backend, like the Nats KV secrets backend, serve secrets for multiple components or providers.
Right, but okay.
I think that
think
it's really important to call out here too that an individual component or something that needs a secret in wasmCloud can fetch secrets from multiple secrets backends. So the diagram in the RFC that has, the host making a request to Vault and the host making a request to Nats KV, that is a core piece of the API. So you could fetch secrets for a component Some of them from Vault, some of them from AWS Secrets Manager. The host supports any number of secrets backends to be configured, since that's all pluggable when you start the host.
So it's basically mix and match as you want. So you have one secrets provider running that can serve multiple backends, Vault or key value, and also serve multiple components or multiple other providers. Is that true? I mean,
Yeah, I think that's my question.
yeah, that's the question. And the confusing part is secrets provider, capability provider. You pulled that example up on the screen because you wanted to show the capability provider, the public key, right? And it's a little bit meta because the capability provider happens to be the secret provider. Is that correct?
Yes,
You know what? This
Something
was a
has to
little bit
be able to
confusing.
talk to Nats KV or Vault or AWS, whatever, right? And
Like
so that has to be
this,
that has to be a provider. But then
yeah.
again, I
okay,
think that's where I was getting tripped up a little mentally in my model. And then
gotcha.
yes, and then other providers can use that or other components can use that. But was the
Yeah,
model like I think all right, whatever. We don't want to rat hole on this, but my thing is like, well, how many of those providers that can actually access whatever the backing store is would we have like in a model of like hundreds of applications on a lattice? Like what's the
okay.
but whatever. So I think it's probably a little bit of TBD on that.
I get it. I think I do get it. I think one source of confusion is that this is called a secret provider. I think we could call this secret Redis, like secret Redis, the KV capability provider that's accessing Redis but authenticated. The actual fetching of the secret is all done by the host itself. Um, I think that I could talk a little bit about that to maybe help clear some of that up. So one example of this is when, so when you send a request to the host to say, hey, start this capability provider, what the host does is it takes a look at all of the configuration that was passed with that provider. And if any of them are, where do we fetch this? Sorry, let me find where I made this. Here we go. If any of the configuration that we pass to this capability provider was actually a reference to a secret, saying, hey, I need to go fetch the secret at runtime, the host is actually the entity that's making a request to the secret's backend to fetch the secret.
Okay.
So uh, we need the secret store to be configured to actually go fetch the secret. So that is one of the things here. If we don't have it, then or if the entity is actually not doesn't need any secrets, then we're all good. But the host will use the identity of the either component or capability provider to fetch the secret. Does that make sense? So we don't actually
Yeah.
need a
But-
yeah.
Okay, so for Nats, I guess the host could just do everything, but like what if there's just some I mean, you don't want to have the client code for every single possible secrets backend in the host, or maybe you do, or do you?
Exactly. No, we do not.
Okay.
This was a big part of us making the secrets backend, the secrets backend API for the host pluggable.
Okay.
When you have a secret reference that's declared that you say, hey, you need to fetch this out of Nats KV, and the key that you need to get is my Nats secret. What the host does is it will validate the identity of the component or the provider, and then it sends a request over NATS to this topic. So
Right.
wasmCloud.secrets.NATPV, this is the backend, and then the version of the protocol and whatever, and then the name of the secret and the version and all of that stuff. And that includes the context of what component or provider is trying to fetch the secret. As soon as you declare a secret that says vault is the backend, all that's changing is this topic prefix. And that's why it's important for the implementation of the secrets backend to subscribe on like this particular API.
Okay.
Does that make
And
sense? It's a similar model to the policy service where the host is just interacting with the NATS API and the secrets backend, which is a separate binary or container, whatever, is the is principal the right? No, it's not that with security. It's the thing that's interacting with the actual secret store itself.
I got it. Okay, makes sense. So everybody on the lattice who, because there's only one topic, wasmCloud secrets vault. So
Yep.
everyone's using that one vault client. Now I get it. That's the answer to my question, I
Yep.
think. I wasn't very clear.
and
I'm not.
the vault client can live anywhere. It doesn't.
Yeah.
I
This
mean,
has to be in the
anywhere where it can listen to a
subscribe.
Nets subject. Right.
Right. Yeah.
Exactly. Yeah. So if you
Cool.
you'd run you could run multiple copies if you wanted, for resiliency. You probably just run the secrets backend as close to the storage plane as possible. Um, right now, I think it's worth mentioning that we have the secrets backend implementation for NATS in the wasmCloud repository. So if anybody's interested in taking a look at how this is implemented, you're welcome to. The Vault implementation should be coming out a little bit either later this week or later next week. And it'll just implement the same API, but in terms of fetching secrets out of Vault.
And the vault one, I'm sorry if I'm totally monopolizing this conversation, but the vault one, will it be storing, well, I guess when you design this client, is it going to be caching so that it'll be caching the secrets locally, or is every request going to, I think I mentioned this like 3 weeks ago or whatever. It would be bad for every single component that gets fired up every so many microseconds to result in a Vault API request, right? So there should be
Exactly.
some sort of, okay.
Yeah, caching is a core piece of it. Like you said, there's no way that we could, have 1,000 components all using the same secret, making 1,000 ball calls all the time.
And do they get cached in NATS key value, or do they get cached locally on the process?
Yeah, so on the host side, we
Cached on the
actually
host side. Okay,
on the
got it.
host on the host side for capability providers, we fetch all the secrets that the provider says that needs, and then hands it to the provider to
Right.
leave to them how they want to cache it.
But for components, yeah.
On the component side, what we actually use is a crate called secrecy. Can you see this little pop up?
Yes.
Okay, we keep a cache in the host components handler, which is wrapping the secret value in this secrecy crate. And the secrecy crate is a nice little handler. It offers a nice utility in the secret type where the inner secret needs to be, you need to call expose to actually reveal that secret. And when you're storing it in memory, as soon as it's dropped, it will, essentially zero out the
Okay.
memory.
And so that's why you're able to keep a single weight interface for any type of backend, because the reveal call is made to this, not to like some other special client.
Exactly. Yep.
I got it. Cool.
Yep. But all of the fetching of this, all the storing of this is all done in a nice encrypted way. If you're interested, you can take a look at the PR of how we actually we have this. Yeah, you can take a look at how we actually did this for the WIT interface. So for the secrets reveal function, we actually only expose that secret at the exact moment where we need to hand it back to the component. Now, I think that there's a good argument in the future for not actually allowing components to reveal secrets. And the reason being is that often when you need to, in this example that I used, where you reveal a secret to check a password is correct, that could be a valid use case. But most of the time, when we're using a secret value, it's really useful on the capability provider side to pass that secret reference to the provider, and then have the provider reveal the secret on behalf of the component. So an example that I wanted to use was If you want to trigger a GitHub workflow, you have to pass a personal access token as a part of like the HTTP request that you make.
Yeah.
I think it would be really nice instead of the component revealing the secret, technically having the secret and then putting it as a header on the HTTP request. It'd be really cool to hand the HTTP client provider a reference to that secret, which then it can resolve only at the time where it's making
Yeah.
the HTTP
I
request.
agree for most cases that sounds right. Although there are some cases where you'd want the component to have it for some sort of encrypted signing or something like that.
Yeah. Yeah,
Yeah, one thing to point out here though too is there's a reason why the reveal part of the API is separate, because technically you can refuse to grant access to the reveal side of things if you want to. That's why it's a separate interface. And so it still is giving the operators the control over that. Like if you don't want something to reveal the secret, then you can say you don't get it. And if it tries, and it'll say I can't satisfy the import for you.
Yeah, because
So
you control within the host.
yeah, so like any platform operator can make sure before they link that specific thing that they want that piece of code to actually be able to reveal a secret. And so what Brooks is mentioning is something that's like down the line, because for that
Yeah.
the kind of thing that's being proposed, this would have to be something that's supported inside of, like WASI HTTP headers or, like that kind of thing. And like this still hasn't been put up as like WASI secrets interface yet. We wanted to get a solid implementation in place before we did that. So
Yeah, I could definitely see like here's a handle. Like you can, I'm gonna pass you a handle to a secret or something. Whatever, and if handle's not the right term, but and then you kind of grant permission to a provider to
like
reveal
a
secret.
secret is a perfect example of what resources should be used for. Resources are not sometimes it's really easy. I've fallen victim to this myself, to consider resources to be a like struct you can dangle implementations off of. What it is, and at its most core, and this is why we've had these conversations in designing a lot of these other interfaces like Postgres, is that it indicates ownership, right?
Yeah.
And in a distributed environment, that means you don't know what that thing is owned by. And so in this case, it's perfect, right? Because you don't want the component to own the secret, but other things like handles to like a database or something else, you like that's what it's supposed to indicate, is saying I own this resource or I have a handle to this resource, is the kind of indication that it gives.
Yeah, I think as it originally started with kind of a criticism of the WASI model over the web browser model was that you can't share, like there's no shared memory, right? Or what you can do in the browser you can't do in WASM time. And I think resource was just like, well, you can share a resource between components. I don't know. That was one of the first knocks on the component model, as I recall. So yeah, I'm just trying to. I don't know. that was where I think that was exactly what they were thinking when they come up with resources. What I'm saying.
They thought about it. Who knew?
They thought about
So
it.
for different direction, for a provider developer now, that would require to sign up for that interface, right? So every provider developer should use that interface then, right, for secrets management. To make, or do you foresee a landscape of different secrets provider interfaces, right? The reveal interface, at least that's the minimum, right?
The reveal's in the host. The host does the reveal. But if you were your provider would have to be able to say, I'm taking in a resource like that. There would have to be part of your WIT definition is like whatever provided resource. I don't know. I'm bad with names. And then you would have to know that on that resource you can call reveal.
That's right.
It would be a secret.
Yeah.
Yeah.
I think maybe two things to clear that up. The provider itself won't be doing any interaction with the secret store, which I think is
That's good. I mean, that's
right. Yeah. It's the host that would be allowing the reveal.
So here was an example of a component that I actually tried. I wanted to see if this would work, and I was a little overzealous. I forgot that for custom interfaces, we needed some additional support to enable serving exports and calling functions with resources over the lattice, which is okay. But an example of an interface, what I wanted to do was have this function called ping secret direct, and this is just a part of our integration test suite. So it's a ping pong where I would be able to import a function where I call, on the provider side, for example, you would call a function on a component, and something that you would get back was the secret resource. And then later, inside of the capability provider itself, you could get that secret resource back from a component and then reveal it, at the time that you needed it. So I think a good example of this would be if we don't build this into our interfaces often today, and that's on purpose. But if you can imagine a key value interface or a database connection interface where when you're connecting with a password, we all know that the password is going to be a secret. Like we shouldn't be passing that around in plain text. So what we can do is pass the wasmCloud wasmCloud colon secrets, or at that time it'll probably be WASI colon secrets, the secret resource. And then the capability provider can reveal that in order to make the connection. But to your point, that does require building in the secret as a first class part of the contract or the interface itself. And so that's why I think one, it's important to prove this out, but two, for secrets to be a first class citizen of the WASI ecosystem, because then we can treat it as such. If you're passing around a secret and you try to pass a secret to WASI logging, we'll automatically, WASM time, WASM cloud, what have you, can redact that secret before it gets logged. So that is the grand vision, that secrets are something that you build into your interface when it should be treated as such.
Yeah, that was my question. Thank you.
Nice. I want to make sure that we have enough time for the rest of the agenda. I got most of the way through what I wanted to show for the demo. Really, all I was going to show for the rest of it was just the rest of the setup in that run.sh script, but that is out there. I added the secrets example as a draft PR, so anybody's welcome to take a look at it and see how it works. Like I said, there's a little bit of cleanup done. I wanted to show you like the hot off the press, this works feature. So I think that we'll be able to talk more and more about secrets as it lands in actual wasmCloud 1.1 once there's a beta out for people to try and use, whether it is the NATS KV backend or the Vault backend. So I think let's go ahead and put a pin in the secret stuff now. There's really great questions related to secrets, and I think there's a good opportunity for the example to make a difference between, or to really emphasize the difference between what a component's doing, what a provider's doing, what a host is doing, and all of that. So taking a look at what we had left on today's agenda, I just wanted to make sure that we had a little bit of time to take a look at the Q2 roadmap check-in. We technically have until the end of next week, until middle of next week, until Q2 is finished. And if we take a look at the roadmap, I think any good roadmap, you're supposed to set a goal past what you're able to achieve. But I want to be fair in that we actually published and brainstormed this roadmap like a little bit into May. So we had a little bit less than 2 months to get done a quarter's worth of work. Now, all of this is approximation, and the numbers don't matter. I think we've seen a huge amount of features, of bug fixes, of contributions go into wasmCloud over this quarter. So I regret nothing. I think that there are huge there are really, really big features going in around, adding the link name on the WRPC invocation header. The Postgres interface is not technically something that will release with 1.1, but it's something that was a highly requested feature for a long time. We've made a ton of improvements to our developer experience around Wash, around the way that we release Wash, which is only a thing that maintainers have to deal with, support for the new WebAssembly OCI artifact type, which was a whole working group in the CNCF and is now proposed as a standard. And we are now, anytime you run wash push now, you're pushing with that new artifact type. So we've done a ton in this, 2 months of Q2. And we'll essentially wrap up this roadmap, I think, with the secret support. That is the big feature that I wanted to. It was the most requested feature when we did the road mapping session. And so I'm really excited to get that pushed out. Probably in a beta type level of support, like a 1.1 beta version of the host for people to try by the end of this quarter. So this is great. I think that there are certainly a couple of tasks that will roll into a Q3 2024 roadmap. Honestly, not even many of these that are left in the board are really large, but I think that that is totally okay. And I personally really enjoyed the road mapping session that we did in Q2. I think many of you who are on the call right now also did that with us. So I would like to maybe take the next week or so to clean up the roadmap itself, and then we can come back in with a new perspective and do a Q3 roadmap. We can do that on the community call, probably not next week, but maybe the week after, and then we can get that done. Yeah, Masood, go ahead.
Brooks, there is a bit of chicken and egg problem with with contribution. Take those WASI key value related issues. Even Taylor and I talked about it some weeks ago. For someone who is not familiar with the real maze that is wasmCloud host side, it's very difficult to kind of know where to start when trying to do this. And because the issues do not have, let's say, hints about where to look. On the other hand, there is no, let's say, a lot of documentation, and that documentation will be technical documentation to look at, to kind of, understand. On the other hand, you just mentioned something. In the past number of weeks, an awful number of great changes have gone in, and they're staying in different PRs and there are conversations about linked names and resources through WRPC and so on and so forth. And, it's like there's a lot of also dependency on some of the other features to become available in order to be able to do something. So, putting some order into what are the dependencies for doing something, or where to start to look in order to contribute to an issue or one of the features in the roadmap, would help people like me, at least people like me who are very new to all of these things, to kind of understand and see where is that they can contribute.
Yeah, thank you so much for that feedback, Masood. I think that that's a pretty multifaceted piece of feedback, and in in general, I think we should always be holding ourselves to a high bar about leaving details in issues, leaving, reproduction steps, where to look, what needs to be done first. And I think just with the sheer velocity of what we've been contributing and what's been coming out on wasmCloud, sometimes features and issues get filed without, full comprehensive, this is where you need to look. This is where, if you are contributing, from a concept perspective, all the things that you need to understand. And that might happen sometimes on the roadmap. I think that is okay. And only because there really just isn't enough, there isn't always enough time to make sure we're always doing the best thing there. What I will say is that any any of these features, and Masood, I think you've done a wonderful job of this. Anytime you are looking for clarification, or, where to look, what needs to be done, is this ready to take? I think that we have a really great, I guess I'm slightly patting myself on the back here, but I'm really talking about all of you. I think we have a great community of people who are willing to step in and help. And if there's information they can provide about, hey, look here, this is where the implementation is in the host. I think we do a really, really good job of that. So please let me know if you feel like we don't do a good job of clarifying after, an issue like that is filed, for example. But this is certainly where I want to make sure that we're properly tagging issues as being blocked if there's a different issue that it depends on, issues being good first issue if it's something that's kind of, a lower barrier to entry to contribute. But no, uh, to kind of wrap that all up, I don't think that any issue the on the roadmap that has already been through kind of the triage or needs more information step should be out of reach of a contributor and have to be a maintainer to implement.
So the all I wanted to say is that maybe it would be useful to lower the load on the, let's say, next quarter's roadmap number of issues, and instead focus on two things, or pay more attention to two things. One is that, like, those base work that is needed in order to unlock some of the features and capabilities that, people like myself need to build on. And the other one is that, putting some hints and those around how to contribute to issues, because then we can take on those issues and, contribute back to the project.
I think that sounds great. I think we, in the next road mapping session, we should take a look. I don't want this to be like an agile planning session, but we should take a look at how many big features, how many small things, how many documentation features we were able to get done in the last quarter. And that should dictate how much work we take on the wasmCloud roadmap. And I think when we're doing this, if we can hold ourselves to a higher bar about how much information we include in the details, it'll increase the ability for somebody to take that from the community, and then we can get even more things on the roadmap done. I think we should take a look at what all we've completed over the last 2 months, though, because there was a lot of work that got finished that was not captured on the wasmCloud roadmap. And that's by design. We can't prevent or we can't predict everything that we're going to do.
Yeah, agreed. Thank you.
Yeah, thank you so much. Let's see, we're getting near the end of the call, so I wanted to make sure to call out really quick our issue of the week, which is a issue on the wasmCloud Go Provider SDK. And there's been a couple contributions from community members like Ritesh, and a community member coming in, Thomas, my apologies, who are working on the provider SDK for Go, which is great. Something that I realize is we have some level of integration and some level of, we have providers that work of testing the Go provider SDK, but there are some really simple cases that we should be able to test out with a unit test. And I filed this issue mostly because I'm more of a Rustation than on the Gopher side. So I could really use some advice from folks in the community who are on the Go side for setting up some unit tests for specific wasmCloud type functionality. So we'd love to work together on this. This is a great first issue if you're looking to get started and you're more on the Gopher end of the programming side. Just kind of holding ourselves to a high bar on the Go provider SDK, I think would be great. Additionally, I also want to call out our documentation page of the week, which is our cloud event list. You may not know that this exists, but under the reference page, the reference section in our documentation, we actually list every single cloud event. This is like the CNCF project, I think, graduated. Cloud Events project, which is essentially if you are subscribed and connected to a wasmCloud lattice, you know everything that's happening in that lattice on the control interface. So like when a component gets scaled up, when a link gets set, when a provider gets started or stopped. This is actually the way that Watm works. We essentially build a realized view of the state of the lattice using these events. And these are really, really useful if you're looking to build out kind of your own type of monitoring and observability here. You know, all those are published over NAT, so they can be traced, all of that fun stuff. And each of these events also has a set of the data that's included in the event and an example response that's just kind of like in JSON of what the event actually looks like. So all of these are in the cloud event format, but the stuff that's in the data all changes based on the event itself. And I wanted to call out this documentation because one, it's really comprehensive. It's great to be able to take a look at this, especially when debugging, if you're wondering maybe what happened when when your provider failed to start. And I know that Lachlan came through and updated some of this documentation over the last week to include information like the claims on the component, which will be increasingly important for the implementation of secrets, where this claims identity is a key part of that implementation. So I wanted to call out those that issue and documentation page, and that reaches the end. Oh, I do want to make sure that we take a little bit of time because WIT RPC is such a core part of our the wasmCloud project. It's how all of our components and providers can communicate over the lattice in a distributed way based on WIT interfaces. There have been a couple of really big movements in WIT RPC or WRPC over the last week. So at this section of the community call where we talk about general WASM, WebAssembly, wasmCloud community things, I wanted to see if Roman, if you wanted to give a quick update on what's been going on in the WRPC world.
Yeah, of course. Thanks. Yeah, so basically, over the last few weeks, I've been working on, reworking a little bit the Rust transport abstraction. And so we should be now way more efficient and also a bit easier to use in Jedi Binding 4, where we, for example, depend now on very standard, we go all in essentially on depending on Tokyo for Rust support. And we also use Tokyo util codec. So all the functionality is built, all the low-level functionality is built on top of these abstractions, which are kind of standard. And it'll just be very quick and fast in implementation. And we also now have this wasm Tokyo crate that I've been working on, which actually defines all the encoding and decoding of all the types which are defined now on model spec. And so given these rework abstractions, now it also allows us to make transports much more easily. And so one of the big things that we now have in WRPC is in fact quick transport. And so it can be used as an alternative to NATS transport. Potentially, eventually, these could be used, simultaneously. It could be complementing each other, where you could use NATS to, for example, do server discovery and then afterwards communicate over quick for quicker. It's funny because it turns out communication, but also for security since it's all encrypted. As you may know, quick protocol in fact is UDP based and it requires TLS. So it's in fact the WRPC quick transport supports mutual TLS, so both client and the server can authenticate each other. And so, in fact, the selection of function you're calling is expected to be within an SNI as a SAN on the TLS certificate, right? So basically, if you're calling foo, for instance, a bar, well, that actually appears in your SAN as foo.bar.client.wrpc. And so the cool thing about it is that you could essentially your provider, let's say, right, in wasmCloud terminology, could specify all of the functions it actually is allowed to export, and you could sign that certificate, right? And the client will, in fact, then verify if indeed it trusts the provider, exposing that functionality. And the same goes also the other way around, where the server can verify that the client is actually authorized to call some function. So I think that's pretty cool, development here, and it's yeah. Any questions, perhaps, on that?
Yeah, that sounds awesome. So, because I know we danced around it with the secrets thing, and now if we're using SNI and mutual TLS, we kind of got the same. We've got like, it's kind of like we're redoing Spiffy a little bit, like give all the little building blocks. But I mean, something with OpenID, like it has to be some sort of OpenID type thing. But it sounds like we kind of are doing it with the component, with the registry of the components and providers and what's allowed to do what. But I think probably just allowing other things that use OpenID to be able to call into the lattice and have that mean something within the lattice. I think that, I don't know, that's probably like what would be nice to have, right? If that makes sense, right? And then the other thing is, NATS, Jetstream. I don't know. In the back of my mind, I've always been afraid, and maybe it's ill-founded, but like, oh no, can it really handle all this traffic? But if the idea is we use NATS for discovery, like if we find that there's a problem, whatever, with the traffic that NATS can handle over Jetstream, the fact that we have this kind of other thing quick, which is definitely made for high traffic. Like that's the whole point, right? I mean, not the whole point, but one of the big design considerations are quick. So that's really great that we have this kind of other option.
Yeah, absolutely. So that's also great. So that's great. This way, it's great that WRPC is transport agnostic. So, like for example, you mentioned OpenID. So the idea is that you could, let's say, wrap this quick transport and then add OpenID on top of it, or perhaps you could, in fact, add it to essentially anything, right? So these transports are made to be also, in some sense, composable. Like one could imagine could have a transport layer which would, say, compress traffic which goes through it and comes back. And so this way you could, like I was saying, these NAS and quick. So for example, that could also essentially, on perspective of this WRPC, it would be just a single transport. But internally, it could in fact use both transports and then do this discovery and then communication afterwards. So it's all certainly, like for example, something like raw TCP transport is also an option, and any IPC, just Unix domain sockets, is really anything goes. And I believe with the unit abstraction, it's certainly much easier to actually achieve that, because in the end of the day, all you need to do is just give two streams, read and write, and then WPC can handle all the rest.
Mm-hmm. Yeah, that's awesome.
Yeah, I remember when we first introduced WRPC on the community call at some point. I know that Roman made a point to say, I designed this in a super awesome way and it's transport agnostic, and here's the NATS one that we're going to use for wasmCloud. And then this is, I think the real benefit of this is a second, implementation of WRPC shows that transport agnostic part. It's really cool. All right, thank you, Roman, for kind of taking the last couple of minutes. I'm sorry I ran you right up to the end there. But if folks have questions or interest in some of the lower levels of how WRPC works, I know that there's a lot of information that we can share there. So please let us know in Slack or GitHub, or make a PR directly to the community agenda if you want to see that kind of thing more in detail, which would be great. All right, folks. Well, I think there could be plenty more that we could talk about, but we're a little bit over time, so I want to make sure I respect everybody's time here. I think we can go ahead and call it for today, but thank you so much for coming out for the